Okay, this first assignment that we're looking at is SP41, and this is actually looking at coefficients in a chemical equation as being moles. And this is a very useful quantity for us because moles are actually easy to measure out. So before we can do anything else, the first thing we have to do is balance our equation. Alright, I'm looking at this equation. I think the first thing I should probably fix is my oxygen. On the left-hand side, we have 2 oxygens. On the right-hand side, we have 3. We have an odd number, and we deal with the odd number by actually timing it by 2. So we put a 2 there. That gives me 4 oxygens on the right, which means I need a 2 on the left to get the 4 oxygens on that side. We have 4 hydrogens. We have 2 hydrogens, so I put a 2 there. That changes my sulfur to 2. So I need a 2 on this side. That changes my oxygens now to 6. So I have to erase this oxygen right here and put a 3. So my equation, I believe, is now balanced. We have 4 hydrogens, 2 sulfur, 2 sulfur, 6 oxygens, and 6 oxygens. So the first question asks us the number of moles of oxygen needed to produce 350 moles of sulfur dioxide with sufficient hydrosulfuric acid. All right, anytime it says sufficient, that just means that we have enough. So we don't even have to worry about that. We can actually just put a line through that and not worry about those words being there. But we have to have hydrosulfuric acid to make this reaction work. So we start with what we have, which is 350 moles, and that's abbreviated capital M, of sulfur dioxide, which is SO2, and we put it over 1. All right, whatever is on top absolutely positively has to go on bottom to cancel it out. So right now, we're going to put moles of SO2 on bottom, and we're going to put moles of what we're looking for on top. And what we're looking for is the number of moles of oxygen. So we're going to put moles of oxygen on top. Now the numbers that go here and here come from a balanced equation. And this is going to be called, from now on, my mole-to-mole ratio. Well, from a balanced equation, I need 3 moles of oxygen. And from a balanced equation, I need 2 moles of sulfur dioxide. The moles of sulfur dioxide cross off. That leaves me with moles of oxygen, which is what I'm looking for. So I have 3 times 350 divided by 2. Comes out to 525. The next question. This time we want to know the number of moles of water formed by 80 moles of hydrosulfuric acid. So we start with 80 moles of hydrosulfuric acid, which is H2S, put it over 1. Moles of hydrosulfuric acid have to go on bottom. And we're going to put moles of what I'm looking for on top. And what I'm looking for is moles of water. All right, once again, those numbers that go in those places come from the balanced equation. So from our balanced equation, we have 2 moles of water, and we have 2 moles of hydrosulfuric acid. Well, if I have a 2 on top and a 2 on bottom, they cancel each other out, which makes my final answer 80. Now, numerically, that is the same number as I started with, but the important step here is that I went from moles of H2S to moles of H2O. So that's where this step is really, really important, is we're going from one substance to a different substance with my mole-to-mole ratio. So now it's 80 moles of H2O. All right, my last step, or my last problem, a little bit extra that you have to do on this problem right here. This question asks for the number of moles of H2S left over if 75 moles of H2S react with 90 moles of O2. Now, normally, every time we start a problem, we start with what it is that we have and put it over 1. But this time, I have 2 numbers. I have 75 moles of H2S, and I have 90 moles of O2. So the first question would be, does it matter which one I start with? And the answer to that is yes, it does. Now, the one we're going to start with is the one that we have enough of. Or in other words, we cannot start with the one we have too much of. And in the first 8 words, roughly, it tells me. It says that I'm going to have some H2S left over. So I cannot start with the H2S. I have to start with the 90 moles of oxygen. So we start with 90 moles of O2 and put it over 1. All right, at this point, I know I have to put moles of O2 on bottom. And what I'm going to do is I'm going to put moles of H2S on top. Because what I'm going to figure out is how much H2S I should have used and subtract it from the amount that I did use. So moles of H2S go on top. All right, H2S should be 2. Moles of O2 are 3. Moles of O2 cross off. And I have 2 times 90, which is 180. 180 divided by 3 comes out to 60 moles of H2S. Now that's not my final answer. The question asks the number of H2S left over. Well, I started with 75 moles. I should have used 60 moles. So with some simple subtraction, I have 15 moles of H2S left over. There you have it. Just a simple mole-to-mole ratio problem.